Hey everyone, we're going to look at Achieve section 2.6 number 2. We have three different cases here that we're going to decide if each set of the inequalities provides sufficient information to determine the limit as x approaches 1 of the function f of x. And if it does, to find the value of the limit. And then it says, otherwise enter DNE, which stands for does not exist. Let me just say this, that this entering DNE in the blank, I've got a problem with that, and I have contacted the publisher to sort of change this question around. So I'll talk about that here in a minute. Let's look at the first inequalities. There's three that are given. This is the first one. You see the function f of x is bounded basically between the two functions 4x minus 5 and x squared. And so what this problem is talking about, of course, is the squeeze theorem. So the sufficient information to determine the limit comes from the squeeze theorem. Real important that we can't just simply say, we're taking the limit as x approaches 1. You can't simply just plug in x is 1 into this and assume the following. So this is incorrect. If I plug in 1, 4 minus 5 is negative 1. X is 1, so I'll have f of 1, and 1 squared is 1. Okay, this inequality is not necessarily true because, right, when we talk about the limit as x approaches 1 of the function, the value of the function at 1 has no bearing on the limit. The value f of 1 may not even exist, for instance, okay? So they really should say this inequality is true only for values of x not equal to 1. And they don't say that, so it's a little confusing to me the way this problem is set up. And I will have that indication on the test if I give you an inequality like this. So in other words, you cannot just simply plug in and determine that a limit exists or not. Doesn't matter what's happening right at x equal 1. Okay. What matters is the limit of these bounding functions. If both of these bounding functions have the same limit, right, then our function gets squeezed to the same limit. This is the squeeze theorem. All right. So what is the limit as x approaches 1 of 4x minus 5? Well, we do evaluate that limit because it is continuous at x equal 1 by direct substitution. So I can plug in x equal 1 and I get negative 1 here. 4 minus 5 is negative 1. Here, I plug in limit as x approaches 1 of x squared is 1 squared, and I get positive 1. So these are the limits. Since these two values are not the same, negative 1 and 1 are not the same, we do not have enough information to determine this limit. In other words, it doesn't get squeezed down to anything. You've got this function 4x minus 5, which is approaching, that's a line of slope 4 or whatever. And right at x equal 1, I should put, I don't know what's going on there necessarily. And then this is a parabola that's opening upward here. And so, what's happening, I'll just put a hole there as well, right at x equal 1, right? The one function's approaching negative 1 and the other's function's approaching height of 1. So there's a gap of 2 units here, and our function is in between these two, so we don't really know what's going on. The function may still have a limit, and that's what I don't like about what the textbook wants us to do here, or what Achieve wants us to do here, entering DNE. Because we still don't know whether or not the limit does not exist from this analysis. We just don't know. The limit still may exist. I can still have a limit in here. My function that's in between these two, we could have a limit. We could be approaching the same value as we get close here. We could be doing that, or we could have a break in the graph. There's enough room for that to happen, to have a jump discontinuity. We just don't know. And so it's really bad that they want you to enter DNE in this case. That's what you're going to have to do. Really what we're saying with the DNE in this case, I think, is that the squeeze theorem doesn't work. We don't have enough information to determine that limit. Only when these two values, these two limits, the limits of your bounding function, your lower and upper function are the same, can we determine the limit. And that's basically what happens with the other two situations. This inequality here, if I take the limit as x approaches 1 of 6x minus 5, I get 1. And the limit as x approaches 1 of x squared, I also get 1. Since these are the same, I can find the limit. The limit as x approaches 1 of f of x is equal to 1. And in the last set of inequalities, we have a similar situation where we see that the limit becomes 12. Okay, so that's the explanation for this one. You can see my lecture video on the squeeze theorem in section 2.6. Refer you to that. I do some more examples there. Okay, I hope this helps.